Hello and welcome to Projectiles at an Angle, lesson 2.4b. What is the big difference between this and the horizontal projectiles before? The big thing is that things are coming at an angle. Now that could be an angle up, that could be thrown downwards, but the point is that it's at an angle, no longer perfectly flush. And so what that means is that the initial velocity has to be broken into x and y components. Y component only. And the velocity here is the x component only. Okay. Here you're going to still see acceleration due to gravity in the y direction. And the displacement is in the y direction is still the height. But instead of a vi is equal to 0, we've got a vi that is something not 0. So you're going to be using your acceleration formulas for the y. In the x direction, there is no acceleration, so you're using v is equal to d over t because no acceleration. It is uniform. It's just that the velocity here is the x component of that initial velocity. Again, as always, time is the same for both. So again, one of the key things we're going to need to do is separate the initial velocity into horizontal and vertical components. And I say horizontal velocity and vertical initial velocity. Let's take a look at an example here just to kind of see how this goes. We've got an object that is kicked, right? So from the ground, 10 meters per second at an angle of 37 degrees from the horizontal. And we want to calculate this distance, this range. Okay. The key thing here is we're going to need to break up this into horizontal and vertical components here. So let's start with that. In this case here, if we're trying to find the horizontal, the x component, we're going to be using cosine because cosine of an angle is equal to adjacent over hypotenuse. We're looking for that adjacent side. And so 10 cos 37 will get us the adjacent side. In this case, that is 8 meters per second. 8.0 meters per second is equal to the adjacent. Using sine theta equals opposite over hypotenuse to find this y spot, right here, this vertical. So again, h sine theta is equal to the opposite side, where 10 sine 37 is equal to opposite. And when you calculate that, it comes to 6.0 meters per second is equal to that opposite side. So that's the velocities in the x and the y direction. This is our horizontal velocity. And this here is our vertical. So we're going to solve this again, breaking this off into that t-chart, dealing with the x and the y. We do want to eventually find this displacement. So this displacement being the question, we know the velocity is equal to 8.0 meters per second. And the thing we don't know is time, but time can be found using the y. Y, we know that the initial velocity is equal to positive 6.0 meters per second. The displacement, it's landing at the same height, so it's got a displacement of 0. Acceleration is equal to negative 9.81 meters per second squared. And we're looking for the time. Now, given this information, using d is equal to vit plus 1/2 AT squared is going to be the go-to formula, where 0 is equal to 6t plus 1/2 negative 9.81 t squared. The issue here is that we've now got a quadratic. Now we can use the quadratic formula. We could maybe solve for VF and then solve for t, but one of the easiest ways to do this is to actually calculate this graphing using our calculators. So in our graphing calculator, we're going to turn it on, and we're going to enter either side of the equation into y1 and y2. So first one is 0, the second one is going to be 6 time, or x, plus 0.5 times negative 9.81 x squared. Close brackets. Okay, so when we graph this, it'll look something like this. It's graphing the first one and second one. We're going to zoom in just a little bit by changing our window settings. X minimum will go -1. X maximum, let's go 6. Let's go -1 and 6. Okay, just to get a better sense of what's going on. There's two intersect points. The first one is here at time of 0, and the second one's here, and that's what we're looking for because we know that it was at the ground when we started to kick it. It went up and down, and so that's where we're going to intersect by finding where they intersect. We press second function, then calc. That's the trace button, and select the intersect. And we're going to just do this with the 3 curve methods by pressing enter, 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 and we find that that's the time of 1.22 seconds. So we've got a time of 1.22 seconds. That is going to be what gets brought over here for time of 1.22 seconds. And now d is equal to v times t. We're going to multiply those two together. 8.0 multiplied by that 1.22 gets you a displacement of 9.8 meters to 2 digits. Because we've got a 3 2-digit combination here, we're going to the 2. So 9.8 meters is your answer. Right? Again, same strategy. The big difference here, again, is we've got these initial, we've got to break the components down, and because this is not equal to 0, the calculation is a little bit more difficult, but we can use our calculator again. Using the quadratic formula, or finding some sort, like finding the final velocity in between, also works. Let's take a look at this next one here, and example 2 is broken up into 2 parts, but we're looking for, again, first of all, how long is the object in the air? We're looking for time, and how far from the base does the object land? Okay, so we've got this object. It's a 25.0 meter per second from the cliff, and it's throwing up 18 meters per second at an angle of 53 degrees. So we're going to need to separate this into the x and the y component. To find that x component, that's going to be 18 cos 53, and to find the y component, that's going to be 18 sine 53. That x component is 10.83 seconds. That y component is 14.37 meters per second. Sorry, meters per second. It's really the y direction that we're dealing with in order to find the time. So all of this is really just dealing with the y, where the displacement is negative 25. The acceleration is negative 9.81. We're looking for that time with an initial velocity of positive 14.37 meters per second. So using our d is equal to VIT plus 1/2 AT squared, that displacement being negative 25 is equal to initial velocity of 14.37 t plus 1/2 negative 9.81 t squared. And again, we're going to solve this graphically. Pulling up our calculator, our first y equals is negative 25. Our second one is 14.37x plus 0.5 times negative 9.81 t squared. So it'll look like this, and we're going to need to adjust our window settings because the displacement is negative 25, so we should go probably to at least negative 30 here in dealing with this. When we graph that, we see here's our first line, our second line. It comes a little bit out, but that's okay. This second section is what we're looking for. We want to find where they intersect. Second function, calc, select 5 for intersect, and we're going to pick the first curve along here, bring the cursor close to where we were looking for, enter, 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 and we see we've got a time of 4.156 seconds, or to 2 digits, 4.2 seconds. The second part is to figure out how far from the base. That's the x portion of all of this, and v is equal to d over t, or d is equal to v times t. We know that velocity is 10.83 meters per second, and the time we've calculated to be 4.2 seconds, and so that range, that overall range, is going to be 45 meters to 2 digits. So this is going up and down with a range of 45 meters. Okay, if you have any questions, please let me know. Oh, sorry, one for you to try. Please pause the video, try this one, see if you get the answer. The answer you should be getting is 57.2 meters. So again, it looks something like this. We're finding our time in the y direction after breaking apart the velocity into horizontal and vertical components. Using the vertical component, we can find the time to be 4.32 seconds. We do keep the calculator answer, and multiplying by the calculator answer here gets you 57.2 meters. Now, if you wound up with a 57.1, that's usually just because of a rounding errors through there, but you're pretty close. Any questions? Let me know. Thanks for watching.